Welcome to TechOps Tribe, brought to you by Automation. Today, we're going to pull back the curtain on the invisible magic that runs, well, pretty much everything. We're talking about the Internet's official rulebook, the OSI model. It's like the secret language that lets every computer on the planet talk to each other.
I mean, really think about that for a second. You hit send on an email from your couch, and boom, it pops up on a screen on the other side of the world. How on earth does that actually work? It really does feel like some kind of digital wizardry. But believe it or not, it's something way, way cooler.
You see, for all these different devices made by all these different companies to understand each other, they all have to agree to speak the same language. They need a common rule book. And that's exactly what we're going to unpack today.
And here it is. It's called the OSI model, which stands for Open Systems Interconnection. And really, the name says it all. It's a way for any open system, from any company, to interconnect. Now, this isn't a piece of hardware you can buy or software you can install. It's more like a brilliant blueprint, an idea that breaks down the impossibly complex job of global communication into 7 simple, manageable layers.
Yeah, a really great way to get your head around this is to think about Legos, right? Each layer of the OSI model is like a specific type of Lego block. It has one and only one job to do, and it's designed to snap perfectly onto the block above it and the block below it. It's this simple, layered idea that brings total order to what would otherwise be complete chaos.
All right, so to really see this in action, let's follow a digital package on its journey. Let's say we're sending that email. That message is going to travel down through these 7 layers, kind of like an assembly line, with each layer getting it ready for its big trip across the internet.
And here they are, all 7 of them. Don't worry about memorizing the names right now. Just picture our email starting at the top, at layer 7, and getting passed down. At each step, a new wrapper of information is added, kind of like a game of pass the parcel, preparing it for the next layer.
Okay, so the top 3 layers all work together to get the contents ready. Layer 7, the application layer, is where you actually type your email. Then, at layer 6, the presentation layer, that message gets formatted and maybe even encrypted. Think of it like putting the letter in a special coded envelope. And finally, layer 5, the session layer, basically calls ahead to the other computer and says, "Hey, get ready, a message is on its way."
Now, our message is ready, but it might be way too big to send as one giant file. So, layer 4, the transport layer, steps in. It's like a super efficient shipping clerk. It chops your email up into smaller, more manageable packets. And, crucially, it numbers each one. Why? Well, so that if a piece gets lost along the way, the receiving computer knows exactly which one is missing and can just ask for it again. It's all about making sure the delivery is 100% reliable. So now we have all these little numbered packets. But where are they going? That's the network layer's job. It stamps each and every packet with the full destination address, the IP address. You can think of this as the full mailing address and zip code. This is the information that lets your data navigate the entire globe, hopping from city to city, country to country to find its final destination.
Okay, we're almost there. Our package is on the right street, but now we need the specific house number. That's what layer 2, the data link layer, does. It adds the local address, called a MAC address. So if the IP address got your data to the right city and neighborhood, the MAC address gets it to the right house on the block. It's all about that final, very specific next hop.
And finally, we hit the road. Layer 1, the physical layer. This is where all that perfectly packaged and addressed digital information gets turned into actual physical stuff. Electrical signals zipping through a cable, radio waves for Wi-Fi, or little pulses of light in a fiber optic line. The package is officially on the truck and on its way.
So, after that incredible journey, our package arrives. Now what? Well, the receiving computer has to do the exact same thing, but in reverse. It's time to unwrap the package, layer by layer, to read the message inside.
And what's so cool is that it's perfectly symmetrical. The process just flips. Layer 1 turns the electrical signals back into data. Layer 2 checks the local address, then tears off that wrapper. Layer 3 checks the global address and tears off its wrapper. Layer 4 gathers up all the little packets and puts them back in the right order. Each layer does its job, removes its instructions, and passes the package up, until, finally, your original email appears on the screen perfectly reassembled.
So you might be thinking, okay, that's a neat system, but why does this blueprint, which is actually decades old, still matter so much? Well, the simple answer is, it's the invisible foundation that our entire modern world is built on.
It really all boils down to 2 huge, game-changing benefits. And these 2 ideas are the reason everything from your phone to your smart fridge just works.
First, there's something called interoperability. Because everyone agrees to follow these same 7 rules, an iPhone made by Apple can send a photo to an Android phone made by Google. No problem. They speak the same language. And second, troubleshooting. When your internet breaks, this model is a lifesaver. An engineer can start at the bottom and ask, is the cable plugged in? That's layer 1. If that's okay, they move up. It gives them a logical roadmap to find the problem fast.
And that's really the heart of it. The OSI model is the universal language for our connected world. Without it, we wouldn't have one internet. We'd have thousands of tiny, separate networks that couldn't talk to each other. It's the invisible grammar that makes our global conversation possible.
But, this whole thing was designed back in the 70s and 80s, and that leaves us with a really interesting question to think about. As we race ahead into a future of artificial intelligence, the Internet of Things, and things we haven't even dreamed of yet, is this 40-year-old blueprint still the right map for the journey ahead?